Welcome to qnawire.
Okay, so the relationship between the changing area and the changing velocity can be expressed with such equation here, which is dA over A is equal to negative dV over V times 1 minus ma squared. So since the velocity is a supersonic velocity, that means the Mach number is greater than 1, because supersonic velocity is greater than the speed of sound. And this will give us 1 minus ma squared is less than 0, which means that 1 minus ma squared is negative. So since the duct is a diverging duct, that means the area is increasing, which means that changing area is greater than 0. So therefore, in order to maintain a balance of the equation, dv, which is the changing velocity, must be greater than 0. So therefore, the velocity is increasing. Since we know there's a negative sign before it, and 1 minus ma squared is negative as well. Negative multiplied by negative is positive. And we know the left side, which is dA over A, is positive. So therefore, dV over V must be positive. And we know V, which is the volume, is a scalar quantity, and volume is always positive. So therefore, dV must be positive, which means that dV is greater than 0. Okay? And for the next question, so we know dV is greater than 0, which means that velocity will increase. If velocity increase, that means the kinetic energy will increase. If kinetic energy increase, that means the internal energy of the gas will decrease according to energy conservation law. So therefore, we know the temperature is associated with the internal energy of the gas. So therefore, temperature will decrease as well. And for the case C, this is the relationship of the changing area and the changing pressure. So if the dA over A is equal to dP over rho V squared times 1 minus ma squared. When the dA is greater than 0, 1 minus ma squared is less than 0. So in order to maintain the balance of the equation, dP, which is the changing pressure, must be less than 0, which means that pressure is decreasing. And for the last case, so this is the equation for the relationship between the area, the changing area, and the changing velocity and the changing density. So when the dA is greater than 0, dV is greater than 0. So therefore, in order to maintain the balance of the equation, the d rho, which is the changing density, must be less than 0. And this will give us the density is decreasing. And these are the answers for this question.